Hi, I'm Mushtak, an undergraduate from Northeastern University, and today I'm going to be talking about language interoperability. This is joint work I did with Daniel Patterson, Andrew Wagner, and Professor Amal Ahmed at Northeastern University, but I'm going to be focusing on my contribution to this project, which was designing a novel realizability model. Programs today often write programs with different components written in different languages, and these multi-language programs run by compiling all of the components to one common target language and linking the components together through a foreign function interface, which is code written in the target that can convert the representation of a value in one of the source languages to the representation of a value in another source language. So in order to prove that these multi-language programs can run safely, we need to prove type safety about the semantics of how these languages interact after they're compiled to a target language and interoperating through a foreign function interface. So what we've done is we've created a model with two source languages, one with garbage collection and the other with manual memory management, which both are compiled to a scheme-like target and interop through a foreign function interface. And we've proven that this multi-language system is type-safe, so any well-typed program in one of the source languages will run safely after it's compiled to the target. And today I'm going to be talking about realizability models, which is a proof technique we use in order to prove this type safety. Realizability models are logical relations which interpret source-level types as target-level terms. Logical relations are type-index relations which capture some property about your programming language, and often logical relations interpret types as sets of terms in that language. For example, the interpretation of the type bool might be the set of terms true and false, since those are the two terms that behave like booleans. But in our case, we have these typed source languages which run by compiling them to a target language. So we interpret types in the source language as sets of terms in the untyped target language. And our realizability model is unique because our target language has both garbage collected references and manually managed references. So our model captures invariance about both of these different features. And now I'd like to give you a taste of how our model is defined. So first, for any source type tau, let v of tau be the value interpretation of tau, the set of target values that behave like tau. And v of tau is inhabited by these tuples w, h1, v1, h2, v2. v1 and v2 are the related target values that behave like tau, but w, h1, and h2 represent invariants about the heap that must hold in order for v1 and v2 to behave like we expect. First, W represents invariance about the garbage collected part of the heap. W is a tuple k psi representing a world, which may be familiar if you've studied logical relations with mutable references before. Psi is a mapping from locations to sets of values. The domain of psi represents garbage collectible locations, but the image of psi represents the possible values that can be present at those locations in order for v1 and v2 to behave like we expect. And on the other hand, h1 and h2 represent invariants about the manually managed part of the heap. So h1 and h2 are heap fragments owned by v1 and v2 respectively, meaning that the manually managed locations mapped to target values, and that these locations and values must be present in the heap in order for v1 and v2 to behave like we expect. So now you can see how W captures invariance about garbage collection, and H1 and H2 captures invariance about manual memory management. And I hope that this description has piqued your interest about our model, especially if you haven't seen a logical relation defined quite like this one before. And I look forward to speaking more about this model and the details about how it's defined in the online poster session. Thank you.